What's up? I'm back with another update video. I did some more reading and review of how HTTP works, and I think I have a pretty good idea of the general blueprint of a HTTP request. And learning that's been pretty helpful because this allowed me to understand what the bytes are going to look like when a message is sent from a client to my HTTP server. And so generally, from what I read on the Mozilla docs, every HTTP request has two fields and then it has a third additional field. So the two fields that you're going to have pretty much every time is the request line and the headers. So the request line is where you actually specify the type of request you're making, if it's like a GET or a PUT or a delete request. And on that same line, you also specify the URL of where you're making that request to. And then headers, you can include what I can gather as metadata about the request, so different information pertaining to the request that you're making. And then finally, you have a body, which is the third component. And the body is optional. I think certain requests, like GET requests, are not supposed to have a body, but other ones, like PUT requests, do usually have a body. So there's two components of a HTTP request which are always there, and then one which is sometimes there. And the request line and the headers are all separated by a new line, right? So it's not all on a single line. So the request line is on line 1, and then headers are on lines like 2, 3, etc. And then between the headers and the body, if there is one, you have a full empty line. So it's not just like a new line where you're pressing enter once, it's like you're pressing enter twice. And in the context of this, that means that you have carriage return line feed, carriage return line feed. And knowing that made it really helpful for me to figure out how we could go about parsing some of this data when it comes in. Because what we're going to get is raw bytes from whatever client is sending a request. But because I know where those carriage return line feed byte characters are, that will help me split up the raw stream of bytes into the constituent parts of the request line, the headers, and the body. And you'll see what I mean in this, like when I show an example. But basically, I was trying to work on the problem of how can I see what it looks like when HTTP requests are made to my server. I guess I could write them from scratch, but then I would have to figure out, you know, line by line, what is it supposed to look like, make sure I'm not making any mistakes, and it seemed really tedious. And so I thought I could just use a tool like curl to send HTTP requests, take the bytes from the curl request, which I know are right because it's a it's a well done library, and then just get used to parsing curl requests. So what I'm thinking is to learn how to write the parsing code for my HTTP server, I'm basically going to use all the different curl request variants on my server and write the logic to handle those various cases. So like for GET requests, PUT requests, delete requests, all of that stuff. And I think that's a good way to go about it. Is using an existing framework like curl where I know that the data coming into my server is correct, and all I have to do on my end is figure out how to parse it correctly and give a correct response back. So let me go ahead and start up the server. You're going to see that the code is slightly different, and I'll explain that really quickly. So let me do python main.py. So now the server is started up, same thing, but take a look at this. I'm using this represent function, which is built into Python. And what this does is it takes the decoding. So here, let me start from the beginning. So we get data from whatever client connects to our TCP server. It sends some data over as raw bytes. We can decode those raw bytes as a string with the UTF-8 encoding scheme. But then what we want to do is we want to find those new line and carriage return escape characters so that we can do some regex to split this whole string up into the constituent parts that represent the request line, the headers, and the body. And so you'll see what I mean. What I'm going to do is Well, actually, before I do any curl requests, let me show you what I was experimenting with. So here, I'm just simulating kind of the structure of what a HTTP request would look like. So this is raw bytes. We've got a first line. You can imagine maybe this is the request line, carriage return line feed. Another line, you can imagine this is maybe a header, carriage return line feed. Here we've got another header, double carriage return line feed. This is simulating the gap, the space between the final header and the body. And so what I was thinking is, assuming that the bytes that are coming in to my TCP server resemble something like this from a valid HTTP request, what I can do is I can first decode it into a string and then use this repr function, which makes escape sequences explicit in a string. So if you have a string that implicitly has escape sequences, using repr will return a string where those characters are explicitly shown. And what it also will do is it'll put an opening quote and a closing quote on the string, which is not needed for what we're trying to do. And so that's why I am filtering to start at the first index and stop before the last index to get rid of those quotes. So let me just go ahead and run this real quick, and you can see what I mean. So let's do Python testing bytes parsing.py. Okay, so what we did was we decoded this string and then we applied repr to it to see what the raw escape characters look like. So we see this is an initial line, carriage return, line feed. Here's a new line, carriage return, line feed. Now this is the penultimate line, carriage return, line feed, carriage return, line feed, final line. So that's exactly what we would expect if we got an HTTP message or a request sent to the TCP server, is that it would have some sort of behavior like this, where these carriage return and line feed characters delineate where new lines occur. And so what that means is that if we look at the raw representation of the string, we can use regex or something similar to it to split up the components of this raw string into the request line, the headers, and the body, like we actually want to if we were parsing a HTTP request. So what I'm doing here is, you see, I'm splitting on a double carriage return line feed, which means that basically I'm splitting the request line and the headers from the body. And that's what we're doing here. Requests and headers are the first index of the split, which returns a list of strings, and then the body is the second index. So let me go ahead and actually print these out to make it explicit. So let's do print. And let me comment this out so we can just make sure we understand what's happening here. So here, we can see this is just the raw representation of the string. If we split on the double carriage return and line feed here and look at the constituent parts that get split out, we see we've got the final line, which happens after it, and then we've got all of this, which happens before it. But then within the requests and headers substring, we want to additionally see where is the request line and where are the individual header lines themselves. And so what we could do is we can look at this requests and headers string and split again on just the single carriage return line feed. And then if we print this, we're going to see that line 0 should be just this first line that says this is an initial line. I'm going to rerun the script. Yep, so the length of the split is 3, because if we look here, that's our first, our second, and our third. And of course, the first one that is returned by the split function is this substring. So that should give you an idea of how I'm thinking about this. So basically the way I'm thinking about it is that I know, because HTTP requests are just structured text, what that means is that I can look at these escape characters in the byte stream and use that to separate these to separate these constituent components of the HTTP request and then handle them individually. So now let me show you, going back to the server that I started. I'm going to pull up git bash because PowerShell doesn't really have curl, I don't think. I think it has something that comes up if you type curl, but it's like a Windows alias for curl, so I don't know if it behaves the same. But what I'm going to do is I'm just going to send some curl requests to this TCP server. It is going to throw some sort of error because I don't actually have TCP, or not TCP, I don't have HTTP handling set up yet. However, the bytes are still going to go through, and that's what we're interested in looking at. So we're taking in the data, we are decoding it to UTF-8, and then we're representing it um, as a raw string. So let's do just a regular default curl GET request. So HTTP :// on port 8080. So here we can see some sort of error happens, but what we see in the terminal is that we see get from HTTP 1.1 and then carriage return line feed. The host is localhost 8080, which is what we specified. Carriage return line feed. The user agent is the current version of curl that I have installed. Carriage return line feed, accept, and then the double carriage return line feed that I talked about, which separates the headers from the body. Now, put requests, I believe, do include a body by default. So let's make a put request. So I think it looks something like this. And I think there's some flags I need to include, but let's just see what this does. Okay, yeah, same thing. So let me look at... So there are two flags I need to use. So... let me see if I can remember them. I think it was -H and -D. -H for header, probably. So -D is for data. So this is sending actual data. So this would be the body. And then where is -H? -H header, pass custom headers to the server. Okay. Let's try another request then and see if we can see what it looks like when we have data being sent. So let's do -D and let's do just like an example JSON object. So let's do okay, yeah, there we go. So we sent this data and it ended up being in the body. As you can see here, put content length 16, content type, application, carriage return line feed, name Matt. So because this name Matt JSON object appears after the double carriage return line feed, what that means is that this was considered part of the body of the HTTP request because it was data. And so I think this drives home what I'm trying to get at in that all of these HTTP requests are going to have roughly the same sort of layout. And by looking at the raw bytes and where these carriage return and line feed escape characters occur, that can help me split up the raw bytes into the constituent parts that I need to analyze to figure out what's going on in the request and how to respond to it. And so that is probably all I've got to share for this video. Tomorrow, I've got some more time to work on this, and so what I plan to do is start writing some parsing logic to take in these various HTTP requests and actually respond back to them. So really simple for GET requests. I will probably have just like a default value that's returned by a standard GET request. But if the GET request includes parameters in the query, then maybe I could choose to return different things based off that. Same thing with put requests, post requests, all of that. But I'm really happy that I figured out that I could use curl to see what it's like to get these raw bytes arriving to my TCP server, because that makes it so much easier to figure out the right parsing logic, because I know that what's coming in on the front end, the input, is correct because it's coming from curl. But yeah, that's what I had to share in this update video. Um, Not a huge amount of progress, but it's pretty big in that I now know how I'm going to at least produce these HTTP requests and start to parse them on my server side. So yeah, thank you for watching this video and have a good one.